Hi and welcome to today's session on 3D trigonometry. So what I'm going to be doing is using our methods that we've used in trigonometry for 2D shapes for 3D shapes to find any missing lengths or angles on the problems that are given. So here we've got a cuboid of a height of 8 centimeters, width of 7 centimeters and a depth of 5 centimeters. And our problem is that we've got to calculate angle ECA. Of course, the middle letter is exactly where our angle is, and the other two letters are either side are telling us where our angle is. So our angle is going to be between E and A. So our angle just in this corner here. So to find this, first of all, I need this length here of AC. So I'm going to be using Pythagoras theorem to find this because I've got a length here and I've got a length here. I could go through steps of using multiple trigonometry for this, but it's just much easier to use Pythagoras in this case. So my AC squared is going to equal my AB squared plus my BC squared. So that's going to be 5 squared plus 7 squared, which is 25 plus 49, which gives me 74. Now square rooting both sides, I get AC being a length of 8.60 centimeters to 2 decimal places. Now I could have given my answer to 1 decimal place, but anytime that your question asks you to specifically give an answer to 2 decimal places and you've got nothing there and only one number, make sure you're putting in a 0 in for your second decimal place. So now I'm going to use trigonometry to find my angle. So first of all, as always when we're doing trigonometry with right angle triangles, we must label our sides. So we've got our opposite, which is opposite our angle, our hypotenuse, which is our longest length, opposite our right angle, and we've got our adjacent, which is next to our angle. Some people remember this as being in between our angle and the right angle. So what we're going to be doing is using what we've got here. We've got our opposite length and we've got our adjacent length, which is what we just calculated. So to work out our angle, we are going to be using tan or tangent. So tan theta or tan our angle is going to equal our opposite over our adjacent, or by substituting in our numbers, 8 over 8.6. Now we're going to take tan from the left hand side to the right hand side, which is then going to become its reciprocal. So tan to the power of -1. If I was going to put this into my calculator, I'll press shift, tan, and then inside my brackets, I'll put 8 over 8.6 if my calculator allowed me to, and then closing the bracket, or inside my brackets, I'll put 8 divided by 8.6, which will give me 42.93 degrees to 2 decimal places. And that is our angle just here. Could also do this for pyramids. So here's my problem here, where I'm looking to calculate my angle EBM. So I'm looking to calculate my angle just here at the bottom, where E is actually the top of my pyramid, and M is the midpoint of BD. This is square-based pyramid, but it would work very well with rectangular-based pyramids also. So first of all, I need to find the length of BD, which is then going to help me find what BM is. So I'm going to use Pythagoras theorem again for this, because I've got the length of the two sides. So my length of BD squared is going to equal my length of AB squared plus AD squared. So 5 squared plus 5 squared, which is 50. And square rooting both sides, BD equals 7.07 to 2 decimal places. Now, I need the length of BM to be able to find out what this angle is, because I've already got my length of EB. So to do that, I'm going to halve the length of BD, which is going to give me a length for BM of 3.54 centimeters to 2 decimal places. Now I'm going to use trigonometry to find this angle just here. So I've got my adjacent, which is what I just calculated. I've got my hypotenuse. So because I've got those, I'm going to be using cos or cosine. So cos or cosine my angle equals adjacent over hypotenuse. Substituting my value, so 3.4 over 8. I'm then going to take cos from the left hand side to the right hand side. Because I'm calculating an angle, I am going to use the reciprocal of cos. So 3.4 divided by 8, which gives me 63.74 degrees to 2 decimal places, and that's my angle just on the inside here. If you like what you see, please subscribe. Thank you very much for watching.